This work presents our recent progress on the problem of irrevocable sample selection. Sampling or sensor selection problems are pervasive in robotics, environmental monitoring, and a variety of other applications ranging from data mining to online auctions. We consider a specific variety of sampling problems that share three common elements. Firstly, we consider streaming sampling problems, where a robot or autonomous sensor has to make sampling decisions in real time. Secondly, we assume that the robot or autonomous sensor is a passive observer of the data stream, either due to a lack of actuation in the case of a static sensing node, or in the case of a mobile robot because the robot is constrained to follow some preset trajectory. Thirdly, although the agent may be able to observe the data stream with high frequency, it must select only a small subset of the observations to physically sample. We assume that the decision to take a physical sample is irrevocable. For example, an autonomous underwater vehicle following a fixed trajectory may be equipped with 5 single-use water samplers. After selecting samples according to some utility function, these samples can, for example, be used to infer a map of the sampled quantity of interest. When the goal of the autonomous agent is to collect a single sample from an independently and identically distributed data stream, this problem can be modeled directly as an instance of the classical secretary problem and solved optimally. This simulation animates the optimal secretary algorithm for a stream of IID data points. The secretary algorithm observes the first 1/e fraction of the data stream, shaded in red, sets a selection threshold based on the highest utility sample observed, and then irrevocably samples the next observation with higher utility than the selection threshold. When applying the solution to select samples in robotics and environmental monitoring applications, an issue immediately arises. Data streams in robotics and environmental monitoring tend to be highly spatially and temporally correlated. This simulation demonstrates what can happen when the secretary algorithm is applied to a noisy periodic data stream. The secretary algorithm chooses a suboptimal sample. This simulation motivates the central question of our paper. Can we choose samples from data streams with spatiotemporal structure and provide performance guarantees on the quality of these samples? Specifically, our work focuses on data streams with periodic spatiotemporal structure. We pose the problem of selecting a set of samples from a data stream with periodic structure as a constrained optimization problem. Using a Gaussian process model of the environment with an information-theoretic utility function, we can exploit the submodularity of the utility function to choose a set of samples from periodic data streams with provably bounded regret. We demonstrate the performance of our periodic secretary algorithm on a 7-year environmental dataset collected at the Martha's Vineyard Coastal Observatory on Cape Cod, shown on the left. If we use our proposed periodic secretary algorithm to choose a set of samples irrevocably from this data stream, we show that our approach stays very close to an offline upper bound, while other state-of-the-art irrevocable sampling algorithms underperform. Our full publication contains details on our framework for informative sample selection, how we derive our performance bounds for the periodic secretary algorithm, and contains our full experimental results.